I think it's time now, and we can open the session with formalities.
Sir, should we begin? Audible?
Yes, Sapna. Yes, we should.
All right. Greetings to all the delegates and participants from affiliations who have joined us today. I'm Sapna, one of the team members of English for Nation, and I gladly welcome you all to the day 2 of the online international lecture series organized by English for Nation, New Delhi, in collaboration with Vasant, Kanya, Mahavidyalaya, BHU. Throughout the series, as we try to engage with several issues interlinked with language, literature, and philosophy, we also try to bring in the contours of crisis due to pandemic and the need to adapt to technology at the same. Now, this definitely requires us to keep exploring our chances and opportunities thrown open before us in the current situation. And as we ruminate over these opportunities, let us also try to evaluate some of these outlets of learning and language for common good. The honorable resource person for the day, Professor Girish Nath Jha, Professor, School of Sanskrit and Indic Studies, Jawaharlal Nehru University, New Delhi, would try to do somewhat the same through his lecture on Panini and formal methods in linguistics. So without much ado, I now invite Dr. Nidhi Vats, Assistant Professor, Department of English, University of Delhi, also the convener for the current lecture series, to formally introduce our honorable speaker for the day to the audience. Nidhi ma'am, over to you.
Thank you, Sapna. I welcome again all of you here on the second day of our international lecture series organized by English for Nation in collaboration with Vasant Kanya Mahavidyalaya, Varanasi. We had a very enlightening session yesterday, and our speaker of the day is Professor Girish Nath Jha. So I welcome you once again. Professor Jha teaches computational linguistics at School of Sanskrit and Indic Studies in Jawaharlal Nehru University. He is also a concurrent professor in JNU Center of Linguistics, Special Center of E-Learning, and is an associated faculty at the ABV School of Management and Entrepreneurship. Professor Jha has previously served as the director of JNU's International Collaboration, chairperson of the Special Center of Sanskrit Studies, and founding dean of the School of Sanskrit and Indic Study at the university. His research interests include Indian languages, corpora and standards, Sanskrit and Hindi linguistics, science and technology in ancient texts, lexicography, machine translation, e-learning, web-based technology, software designs, and localizations. Professor Jha has many books published from the publishers, very eminent publishers, Cambridge Scholars Publishing, Springer Wellbers, and has over 137 research papers, publications, including 26 indexed at Scopus. He has also delivered over 224 invited talks. So the credential and the expertise of our guest speaker is so extensive that can take a lecture, a whole lecture in itself. So not wasting your time, I'm again inviting Professor Jha. The title of his presentation will be Panini and Formal Methods in Linguistics. Over to you, sir. Welcome once again.
Thank you, Dr. Nidhi. Thank you, Dr. Yogesh, and the English for Nation organization for inviting me to this prestigious lecture series. I'm so honored to be here. Can everybody hear me correctly?
Yes,
yes,
sir.
Okay.
Yes,
wonderful.
Yes.
Now I'm going to share my screen. Okay, is my screen visible?
Yes,
sir.
Yes, sir, we can see.
Okay, so thank you again. I'm so honored to be part of this prestigious lecture series, English for Nation. And I've been wondering, well, people talk about Indian languages, 22 Indian languages, and call them national languages. So English also is equally important, and it's not a scheduled language, but it's really a very important language of India. So I was very happy to see the title English for the Nation. Thank you once again. So I'm going to talk on Panini and his importance in formal linguistics and computer science and artificial intelligence, and how Panini is more suitable for computing languages and helping in artificial intelligence. I'm going to talk about that. So you may have seen this stamp, Panini stamp, released in 2004. We have given this much credit to Panini officially. Well, he was a resident of Takshila. His father was Pani, so he's called Panini. 7th century BCE is the date. And after Panini, the Indian linguistic tradition actually came to be divided into two phases, pre-Paninian and post-Panini. And I've adapted this material from Professor Kapil Kapoor. So if you see pre-Paninian phase in the linguistics in India, surprisingly it was descriptive. And normally you would imagine, and the criticism that goes against India is that India's tradition, linguistic tradition, was normative, prescriptive. It wasn't that actually. It was actually very descriptive and empirical analysis of language usage, speech and recitation. The problem was it was mostly oral tradition, and to make sure the knowledge is preserved and propagated correctly, we have to have very strong, powerful, and very accurate linguistic sciences developed. Therefore, as you would see, the 4 out of 6 Vedangas were actually linguistic sciences. So there were 6 Vedangas: Vyakarana, Shiksha, Chanda, Nirukta, Kalpa, and Jyotish. And Vyakarana was grammar, Shiksha was phonetics, Chanda was metrics, and Nirukta was etymology. And so it was considered that unless you know these 6 disciplines, you cannot understand Vedas. And 4 of these 6 disciplines were actually linguistic disciplines. Now, each of these disciplines had its tradition of scholars. And so Shiksha Pradeshakya, the phonetics tradition, and the Vyakarana prospered with a lot of series of linguistic works. As far as I understand, there are more than 100 texts of phonetics still waiting to be edited and translated. We have done a couple of translations in our department, like Atreya Shiksha and Charani Shiksha. And Vyakarana has been a huge tradition in India. And Yaska's Nirukta also was very important. All these were done so that Vedic texts could be interpreted correctly, because there was an oral tradition. And there were attempts to create Vyakarana, attempts to codify Sanskrit language. It wasn't called Sanskrit at that time, it was called Bhasha or Lokiki. And you can see there were trained grammarians before Panini. So that is a proof that there was intense activity already happening, which culminated in Panini. So these grammarians were Shakatayan, Gargya, Apishali, Kashyapa, Galava, Bharadwaja, Chakravarman, Shakalya, and Sphotayana. When Panini's Ashtadhyayi came in about 7th century BCE, that when we say that the tradition finally matured, and the text of Ashtadhyayi, we'll talk about that a little bit more in details. Basically, an explicit rule-based description, very, very explicit, methodical, and programmatic, systemic. And it has 2 sets of rules, describing the current Laukiki, the spoken language as you would find people speaking and conversing with each other. And the other was, of course, the Vediki, the compositional language in which the Vedas were created. And the post-Paninian phase, if you call it, 7th century BCE onwards to modern times, we had Panini to Patanjali, about 900 years. And we had Ashtadhyayi, and from Ashtadhyayi to Mahabhashya. Mahabhashya is a great commentary. And it started examining, each rule of Panini, whether the rules still make sense after 900 years, and whether they still apply, when language would have changed. And from Patanjali, which is 2nd century BC, to Bhojaraj, 11th century, again 900 years, you had Mahabhashya, to Saraswati Kantha Bharanam, the text of Bhojaraj, 11th century roughly. So again, 900 years and movement from empirical studies now to a little bit of philosophical and literary studies and language. So we started moving from the empirical studies to Sphota, philosophy of language, origin of language, and language and mind, a little bit, language and philosophy, literature, etc., etc. And there was also a big tradition on interpreting Ashtadhyayi and Mahabhashya. Exegetical work was also done in a good tradition, actually, continuous tradition. And then from 12th century onwards to Nagesh Bhatt, which in 19th century, we have two very important texts here, Prakriya Kaumudi of Ramachandra and Paribhasha Indu Shekhar of Nagesh Bhatt. Nagesh Bhatt wrote many texts actually, but this one is the most important one. So in this tradition, basically, we started simplifying, the reordered text, and so that the students can understand Ashtadhyayi. So there was an attempt to make a pedagogical system out of Ashtadhyayi. In the modern times, Panini has been interpreted and understood and studied in many ways. After the work of William Jones and so-called discovery of Sanskrit, there were a lot of translations of Sanskrit texts, and Ashtadhyayi was also translated and studied by Westerners. I will talk about those, the series of great scholars who studied Ashtadhyayi. But before that, Keelhorn, French Keelhorn, Bhandarkar, Chardev Shastri, Katre, Dandekar, etc. They did phenomenal work, actually, lexicography, Panini's text, etc. And then there's another tradition of what is called computational analysis, which I do, of Ashtadhyayi. And they're talking about Panini as a model for Indian languages, computing, and also artificial intelligence. Now, we have talked about Ashtadhyayi, but have you seen the text of Ashtadhyayi? Let us see the text of Ashtadhyayi. And can everybody see this text? Hello?
Yes, sir.
Is it visible? Panini Vyakaranam?
Yes, sir.
Good.
Yes, sir. It is visible.
Right. So Ashtadhyayi has these 14 Shiva Sutras. He was a Shaivite, and it said that Shiva gave him the boon, and so these Shiva Sutras are basically very well organized sound classes, and we'll talk about that a little later. And this is the actual sutra part, or the 4,000 sutras set of Ashtadhyayi. Is the first adhyay, first pad, first chapter, first section, and sutras start 1, 2, 3 like that, a running text. Then we have second, third, fourth, etc. The last chapter and the fourth section and the last sutra. So 8, 4, 68 would be this sutra. So 111 is Vriddhi Radesh, and the 8, 4, 68 is Iti. This is Ashtadhyayi, running text. And students were told to remember this as a song. As you know, in India, mathematics, linguistics, and many of the texts were memorized as a song. And this is what you do if you want to memorize things like that. Now, so 8 chapters, adhyayas, and each chapter has 4 sections, so 8 into 4, and then each path has sutras, or we call it aphorism and statements. So approximately 4,000 sutras are referred as x.x.x. So adhyaya, pad, and sutra. For example, the first sutra with Vriddhi Radesh, Vriddhi is defined as At and H. In any good grammar, in any good formal grammar, in any good sophisticated program, we start with defining things first, meta terms, and then we start using them iteratively in our code. So Panini does exactly the same way. He starts defining his meta terms right in the beginning. So Vriddhi Radesh is 111 x.x.x. The last sutra iti. Is that is 8, 4, 68. This is how you would refer Panini sutras. Now, looking at Panini from my perspective, I call it systematic perspective. I see Panini as a functional functional software trying to mimic human brain, human capacity of conversation and language. So for example, I'm talking to you through online mode, fine, but then you have a sound interface, a phonetic interface in your brain, which receives my sounds and kind of transcribes them into letters, or so to say, or language. There's speech, like speech is the spoken part, language is the written part. And then from the transcribed language, your sutras, the rules in your brain, your language rules of English in your brain, you start parsing them. And after the parsing is done, it makes sense. Whatever I'm saying starts making sense to you. And in parsing that, your brain needs help of lexica. And these lexica are actually the verb roots of the language of English, verb roots. If you don't have the sense of English verbs in your brain, you can't understand what I'm saying. Similarly, you have many of those words which are, just like that, stems. They can't be derived from verbs, so we call them ganas, or rudimentary elements. And then there are small lists which may not be external like databases and big databases, but they might be internal, and which might be referred to by the sutras as and when needed. So this is normally a model of an intelligent brain which parses human speech. So Panini actually is trying to suggest that human brains have something like this, which we have to actually explore a little more detail, in a little more details. Otherwise, the whole field of cognitive science, artificial intelligence, will not be successful. So we have to. So Panini assumed this kind of structure in human brain, and we have to now, approach it a little bit more, experimental manner to prove or disprove Panini. Now, from a model's perspective, I find Panini more formal and therefore more implementable. There are many models which can't be implemented. Models have to be very simple, and so that it could be easily implemented. But some models are not simple, very, very difficult and complicated. So Panini's model is more simple, more formal, and largely unambiguous procedures. So therefore, you can easily program it. And the structure of the entire grammar is similar to a program. If you have seen a computer program, a good program, I would say, not a beginner's program, a sophisticated program, it starts with something similar to what Panini does actually. You start creating variables, global variable, local variable, or instances of classes and functions, and Panini does all that. And then you use them iteratively in your code. So you build a code string using these variables, right? And to understand that code, those variables have to be evaluated. Vriddhi has to be done. Expansion has to be done. Therefore, the first sutra in Panini, Vriddhi Radesh, people say, the traditionalists would say that is Mangalacharan. Panini, normally, if you're in India, we start with Mangalacharan. And my assumption is that Panini is trying to tell you that unless you do vriddhi, constant vriddhi in my code, you will not be able to understand my code, which is very, very mechanical and compact. So, for example, vriddhi is used as a word in many, many sutras. And to understand that sutra, you have to expand what vriddhi means, in the first sutra of Panini. So you have to keep on going back and forth. So the phrase structure rules and replacement procedures and the production mechanism in the formal language theories may have been influenced by Panini. Let's start with the term may now, which our hypothesis would be to examine this statement whether the phrase structure rules and replacement procedures were actually influenced by Panini. Now, Panini's model can also be used as a template. So I would like to use the word templating, whether I don't know whether that word exists in English or not. So something which can be used as a template, right? So therefore, it has cross-linguistic applications. You can use Panini not only on Sanskrit, which is an example that Panini has used, but across many other languages. And I would like to show how you can use it. Now, phonology, for example, is a component where you can apply the concepts in Panini and phonology and phonetics across languages. Now, the concept of human speech, for the first time, what exactly human speech is, it's a systematic production mechanism, place and manner of articulation and variation. All that have been discussed in great detail in Indian texts, and Panini has kind of compacted that in his 14 Shiva Sutras, etc. As you saw in the beginning of the text, Shiva Sutra kind of compacts all that. And then creation of sound classes by way of pratyahara. So if I say aka is a term created from the Shiva Sutra. So a, I, u, ril, rik, and ayong, ayoj, etc. Is pratyahara in the Shiva Sutras. And from Shiva Sutra, you create a pratyahara. So ak would mean a, I, u, ril, ri, 5 vowels. So you draw these sets from across the Shiva Sutra, 1 to 14 Shiva Sutras, organized in very clear order. I've been recently trying to extend the Shiva Sutra to other Indian languages, and trying to understand what additions and deletions you would require in the Shiva Sutra. Now, morphophonemic rules, the combination when sounds combine, there'll be changes, in the synthetic languages, for example, Sanskrit, etc. So the rule writing in generative phonology is very clearly influenced by Panini's rules. Let's look at the rules. One of the rules in Panini says, akaha savarne dirghaha. Ak becomes dirgha. Ak becomes dirgha if savarna follows. So ak produces dirgha in the context of savarna. Savarna is a vowel of the same place and manner of articulation. Tulyasya savarnam. Asya, in the same place and manner of articulation, it's called Tulyasya prayatnam savarnam. Now, in phonology today, you would write the same sutra as this: plus vocalic becomes lengthened in the context of plus vocalic and savarna. This is how, this is not sequential, it goes down, but this is how, if you have done phonology course, you would be told how to write rules in generative phonology to begin with. Similarly, morphology syntax, basically this is a universal kind of mechanism that Panini talks about. So we have a universal base in a fixed model, then in inflectional derivational morphology, very clearly defined idea of verb roots, very abstracted verb roots, nicely arranged in a separate database. And we have nominal stems, stored separately, and then the idea of abstract lexicon. All these are given in the morphology or syntax, morph syntax component. Now the syntax semantics component again is universal in nature. We have what is called Panini's Karaka Vibhakti model. Adonai in 2004 gave a formula to qualify or characterize Panini's sentence mechanism, sentence forming mechanism. I'll describe this formula later on, but this formula can be applied across, any language can actually explain its sentence formation by this rule. Basically say there is a noun phrase and the verb phrase, and these are connected by Karaka relations. And unless these padas, the noun pada and the verb pada, are connected by a relationship, it doesn't become a sentence to be used in society. Now, the modern dependency annotations of languages, Google does that a lot, and a lot of deep machine learning based data creation is getting done using dependency annotation. And so certainly it can be used across. One of our students is actually exploring the Panini and dependency annotation for Hindi and Oriya and comparing it with the Tasniya dependency, the differences and similarities, etc. Why is Panini considered the founder of formal methods in language description? That's the question we sometimes think. Why is Panini considered the founder? Let's examine. We start with some of the quotations. Leonard Bloomfield, in his book Language, gave this famous quote: "The descriptive grammar of Sanskrit, which Panini brought to its perfection, is one of the greatest monuments of human intelligence. Remember, this one is very important, and an indispensable model for the description of languages." This is what attracts me more. We cannot do away with Panini if you have to describe language A, B, and C. For example, in Indian departments of linguistics, if you are working on a model for Hindi or Punjabi, Gujarati, etc., look at Panini first. And then if Panini doesn't work, then look at some other models, right? So we have to use Panini to describe natural languages, an indispensable model. Another very famous quote from the Encyclopedia Britannica. Now, it says that the grammar in Ashtadhyayi has been likened to the Turing machine. Turing machine which came in the 50s. I'll talk about that a little later. And it was a mathematical model of what a computer can do, what a computer cannot do. So Panini's grammar has been compared to a Turing machine. And it says his grammar is generative as well as descriptive, with its complex meta rules, transformations, and recursions. Now, Moriah Williams says that the great linguist Panini gave the concept of meta language and constructed 1,000 of years before computer scientists began exploring the same idea. Now, we in computer science, we start with these terms, these meta terms, meta rules, talking about how the rules will interact with each other, interfaces interacting with interfaces, elements interacting with elements. Right? We don't talk about data right away. We talk about the data holding elements which hold data. And no one has been able to match him to this day. That's what he says. Now, Noam Chomsky is the person who gave what's called the formal theories, which are used in computer science, and which was actually later on extended to creation of the compilers, etc., etc. So let me compare Panini with Chomsky's models. Now, in '65, Noam Chomsky came up with a book called Aspects of the Theory of Syntax, and the model of grammar. He talks about a mental grammar, a universal grammar, the language acquisition device. The mental grammar model, kind of a blueprint that he comes up with, is very similar to what Panini has. So what Chomsky says, that human brains have a base component which consists of phrase structure, rules, and lexicon. Now compare this with Panini's Sutra part and the dictionary, the Dhatu part, Gana part. Dhatu part, Gana part, and Sutra part. This is what is base component. And when language goes through it, you get deep structure. But Panini has one more component before, which is the speech component. The language has to pass through speech component, then pass through this component to get the interpretation done. And from there you go to semantic component. This is Panini's Karaka Vibhakti component. And then when you get the understanding, you apply transformational rules and you get the surface form. From there you go to the phonological form. So I hear the language, parse it, understand it, make response, and then speak it out. So this is the model that the Chomsky came up with. It's a very, very good model, certainly. But it's a very close parallels with what Panini gave 2,500 years before. Now, Panini's comparison with context-free grammar. Context-free grammar are used actually for compiler designs. So let me compare Panini with that. So a context-free grammar, G, is defined as a combination of non-terminal items, terminal items, production mechanism, and the start symbol. So V, T, P, and S. Now, what is V is a non-terminal? For example, you have noun, phrase, verb, phrase, determiner, noun, verb, etc. And Panini would have defined it already as Aka, Savarna, Dirgha, Vriddhi, and all these terms, Sangya Pada, Kriya Pada, etc., etc. All these were defined in Panini already. And terminals would be actually the words from the language, And Panis would be, of course, the actual elements, even the sounds of the language, including the words also, both. And P is a production mechanism which is very well defined in Panini. So in CFG will say alpha, A goes to alpha, where alpha is a string of symbols from V union T star. Basically alpha is a string of symbols which comes from a set of all the terminals, all the non-terminals combined. So if you derive any word, make any word, for example, if I say sentence goes to NP, VP. So NP and VP are actually alpha. It's a string drawn from this, which is non-terminal as well as terminal combined, right? So this is the alpha, A goes to alpha. Parni would say A goes to B if C. Parni has this, fashion of writing rules in entire grammar. And there's a start symbol, of course. Parni's start symbol starts much earlier, actually. It's the vivaksha. I get a desire to make a speech, to speak something, and we start from there. Now, Parni's comparison with Bacchus-Naur form, which is called BNF, the BNF notations are very popular for expressing grammar, an artificial language grammar, through CFG. If I express an artificial language grammar of C, grammar of Java, etc., through CFG, I would use Bacchus-Naur form notations. This is how I would use it. So a sentence, a string would be defined as expandable into two elements, a noun phrase and word phrase, two more entities, right? And again, each of these entities would be further expandable. In Panini, you would call it P. So this is P in Panini, and pada goes to super and thing. Panini says sup thing and the padam. So pada is something ending in a sup or ending in a thing. So Ramaha is supanta, supa anta, and pathati is thing anta. These are padas in Panini. Normally, noun phrase would be determiner and noun in English, and Panini would like us to believe sangya pada would be some flexible sangya and preceded by n number of qualifiers. So there could be 0 to n number of qualifiers. Devadatta, Sundara Devadatta, Sundara Chatura Cha Devadatta. It can be like that. Similarly, verb phrase would be a verb followed by noun phrase in English and non-verb final languages. But in Indian languages, Kriya Pada is can be Kriya preceded by some element, and of course optionally followed by some element. Some languages. If I want to use Parni's template for English, I can use this structure also. And then N can go to all the verbs, all the words in the language. Similarly, S Sangya can go to all the words or elements in Sanskrit and Indian languages. V can go to verbs, and Kriya in Sanskrit can go to the more abstract entities, bhu, ad, etc. These are much more maximally defined elements. So chase is a verb in English, which can be used in a sentence. Bhu is a verb in Sanskrit, cannot be used in a sentence unless you expand it. These are compacted forms stored in databases, meaningfully in good structures. So similarly, we have this element in English language. We don't have these in Indian languages. Now, idea now I can very clearly say obviously came from Panini, because the describing natural language or even programming languages exactly using the right tools wasn't there. I would say in the Western linguistics, of course. Before Panini, this idea wasn't there, and long after Panini, in the 20th century, these things were understood by the Western linguists, and once they understood it, they started developing it in many directions. So I would say from Panini to Ferdinand Saussure, who taught Panini for 30 years, and from Saussure, Bloomfield got the idea, and from there, Gilling Harris, and then Noam Chomsky's series of works, and then John Backus at IBM, who gave to Backus normal form, and then Peter Knorr expanded it, developed it further, and finally it was called Backus-Knorr form, BNF. It was also called Panini-Backus form and Panini-Knorr form. But now currently it is called Backus-Knorr form or BNF. The Panini's technique and abstract notation system used to describe natural language is very similar to John Backus, who described a new programming language called IAL, later on Algon. The Panini's technique of describing Sanskrit, artificially, mechanically, correctly, unambiguously, gives idea to people, who use the similar technique, expanded on Panini's technique, extended Panini's technique in describing artificial languages. And so we got Algon, the programming language. Now, if you have such grammars, good grammars, a formal grammar like Panini, or Chomsky's tradition of grammars like HPSG, can we use them to model natural language sentences, which is the most important task in artificial intelligence? So how can we use that? So the series of grammars that came up, I would call them all in Panini's tradition. But let's see, after Panini 7th century BC, we have, of course, Chomsky laid the foundation stone of all these works. Chomsky itself wasn't implemented because of a lot of issues in government binding and minimalism theories. They were basically theories, not really, I would say, implementable models. So lexical functional grammar of Bresnan, actually, in 1982. Function unification grammar of Martin K. 84. Pre-adjoining grammar of Arvind Joshi and Shavelsi University, Pennsylvania. And Hay-driven phase structure grammar of Pollard and Sag, 1994. Now, all of these basically try to model natural language sentence in a very artificial way, and try to address the issues of, I would say, long distance dependencies, anaphora, etc., in their own way. Now, how do we actually use such grammars and lexicon for parsing natural language sentences? So we'll take a parser, any parser, a natural language parser, which is a program actually, which implements a certain algorithm. For example, I would say Prolog, it's a language, Prolog language parser, implementing early algorithm, Early's algorithm. And we plug in the grammar and the lexicon, which of course have to be as per the parser's requirement. So for example, I take a parser X, which is modeled on algorithm A. We have to have a grammar and lexicon also in the same fashion. And after we plug in the grammar and lexicon with the parser, then parser is considered grammatically trained in that language, or it becomes knowledge rich. And then parser can listen to us and examine sentences and give analysis. But if the parser is not able to give only one analysis of a sentence, then we consider that parser ambiguous, or the grammar which force parser to give multiple outputs, the grammar as the ambiguous grammar. But if we think that our grammar was good and the parser is good, there's no problem with the parser or the grammar, the language itself must be ambiguous. Some sentences in languages are actually ambiguous. So grammars would report certainly more than one output. A parser will be reporting more than one output. So we can have a look at a sample grammar, which I actually wrote for a fraction of English language for my master's thesis at UIUC, Illinois, Urbana-Champaign. So I would basically look at the English commands. I was trying to parse English commands for connecting into database, automatically. So I would say in English language, a database would understand in its own language. There was a translation program which would translate ordinary English commands into database language. So you see how this grammar is written. We start with meta terms, the same way as Panini does Vriddhi Radhesh. He would define Vriddhi Radhesh, gun, etc., etc. So these terms are defined first: dry transitive, verb intransitive, and then in grammar, you use these vocabularies iteratively. And then in lexicon, you use vocabulary. So in the lexicon, you see, if I have to define the verb create in English, I call it, it's a ditransitive second person present tense. This is the word create in English. So we have defined these terms above, and then we are using them iteratively. Panini is exactly the same way. So this would be a grammar for language A, B, and C, and that grammar has to be written as per the parser's requirement, and then that parser becomes trained, and it can listen to your sentences and give responses like this. So the parser can actually parse. So if I tell parser, find the records that have this value, normally a CEO of a company, he has to query his company's database. He doesn't know the SQL language, structured query language. He knows only English. So he speaks in English, and the machine translates his English into the query language, and database is able to understand and respond back. So that was the research that was done. The idea is that you can use Panini's model exactly the same way as we have been using formal languages of today. Now, AI today basically is a very different kind. We have now been training algorithms with a lot of data. We call it machine learning based algorithms. But earlier, before this decade, till 90s, we had formal grammar and lexicon based computing. Where you would hook a formal grammar. I just saw in my code, I had a formal grammar and lexicon connected to the parser to train the parser. Now we don't do that anymore. Instead, what we do, we look at the language sample, we give annotations, grammar annotations, part of speech annotations, all the semantic annotations, morphosyntax, syntax semantic annotations, and then plug that in, and the algorithm learns from that, and so to say acquires grammar. This is how we say. So machine learning based training in the systems has been the current trend in artificial intelligence. And I will say in both the cases, Panini can help. Now, AI has moved to machine learning with a specific reason. Now, natural language data, which is the major goal of artificial intelligence, unless machine understands natural language data, machine cannot be intelligent, period, right? So that is the goal of machines to be intelligent, that you have to understand. And the Turing test that Turing machine, the Alan Turing said, was basically this, that machine has to fool you that yes, it is as good as a human in speech. So machines have to understand human language as we understand. Then machines can be considered intelligent. But natural language today is very, very mixed, very, very variable, a lot of uncertainty, a lot of noise, complexity. So it's a big challenge for machines. Look at the language that is used in human conversation today. And large quantities of data are actually available on the web. This data is very diverse, very complex, mixed, and we call it big data because this keeps on getting created on the fly in big quantities. And there are a lot of other properties of big data, and all of that is available actually. Now, applying grammar lexicon with classical methods of AI in such noisy data will not yield good results. If I want to use the same method of creating a computational grammar or a formal grammar in a lexicon and try to bootstrap a parser with that, it will not work because there will be a lot of ambiguities. I remember I used to get 14 parsers for a very simple command sentence in English language. 14 parsers, Now we talk about, the complete language, mixed language, variable language, half sentences, partial sentences, all those things, code switching, code mixing. It will be very, very difficult to use grammar and lexicon method anymore. So therefore, what we do now, we use the machine learning machine learning methods. If we use the classical methods of grammar and lexicon, we will not be able to build any useful AI system. A useful AI system would have to be very, very robust. I'll give an example. For example, if you want to parse Hindi today, Hindi is mixed, with English. So robust AI system has to, for example, Amazon Alexa, a Google Assistant, must understand mixed Hindi, which is called English, right? Any AI system which is going to parse or digitize Sanskrit manuscripts has to be smart in all the Indian scripts, which were used to write Sanskrit language, not only Devanagari. And also, the manuscript is historical, language is historical, technical. So very, very complex scenario. So using grammar lexicon is not going to be feasible anymore. So we have come to what is called machine learning based methods and algorithms. And I will try to tell you how Panini can be helpful here also. Now, some of these very popular machine learning methods and algorithms which are being used, conditional random fields, support vector machines, Bayesian networks, maximum entropy, neural networks, deep learning, and a lot of other things are coming up. We have BERT algorithms, multilingual machine learning algorithms by Microsoft, Google. A lot of these people are coming up with their own. Amazon has its own, platform. So a lot of these companies are coming with their own platforms. Now, why Panini could be a better model for AI in the current scenario? Now, the two arguments. One, that AI has been changing chaotically, right from the 1950s. AI has changed dramatically, and starting the decade of 2000, this change has been crazier. We are changing much more faster today. So number one, it is chaotic. Change is chaotic. We don't know where AI is going to go tomorrow. So AI is unstable. Number two, AI is still not looking at very deep relationships, which hierarchies, which hierarchies in natural language are encode. It's not looking at that. It's very, very difficult actually. So we have to tell you that Panini can help in both the aspects. Let's first look at the evolution of AI over the years. Since 40s, we have changed every decade. We have changed our emphasis. In 40s, from encryption, decryption, etc. 50s came the machine translation. Machine translation came before the word AI was coined actually. And then theoretical informatics and psycholinguistics, and to the logic, inference, etc., etc. And today we are actually in the big data scenario with the internet, a lot of data available. The AI has suddenly taken a turn towards using this data which is available on the internet through training algorithms automatically. So future is very uncertain. We don't know where AI is going to go. Let's look at Alan Turing and his computing machinery intelligence, what exactly he visualized. So he gave a paper, can machines think? And he gave his basic argument. And those days, the focus was something very different. These days, focus is very different. But his argument that machines can actually think laid the foundation stone of the modern developments in artificial intelligence. Now, AI has been evolving faster, and constantly evolving techniques in AI have been complicating the problem. Now, if you look at a typical course in AI today, if you do a course in AI, you will have a series of machine learning courses, right? If you did a course in 90s, I did a course in 1997 in the University of Illinois. The course was called Introduction to Artificial Intelligence. And the course was only programming in Prolog and Lisp, these two AI languages. So we have changed dramatically, last 20, 30 years. But Panini has been stable for 2,500 years, right? And there were criticisms on Panini, but again, people should examine them much more deeply and prove them wrong. So Panini's model and the broader interpretation, model in Sanskrit, should be explored more closely by the AI community. I'm saying that with more conviction because I came from software industry to JNU, and I combined linguistics, computer science, Sanskrit, and I can say that this is going to be very, very productive for the AI community if they look at Panini a little bit more closely. Now, AI can happen, as I said, only when machines are able to understand natural language like humans, right? We can understand a natural language sentence even if it is used ambiguously, because I have a lot of other channels open. I know you as the speaker, I know the context, the environment, and I'm able to parse the natural language string unambiguously. To make machines understand natural languages unambiguously, we need programs, as John McCarthy, who coined artificial intelligence term in 1955, he says, we need programs which can translate natural language text into collections of sentences in mathematical logical language. Mathematical logical language. This is an important phrase. Let's remember that. He again said, John McCarthy, he sounded quite frustrated, when he died. He says, he says the knowledge needed for people to speak to and understand each other is mostly not encoded in human language. So basically, the sentences that we use, there's a lot more knowledge which is outside the sentence, which we use to produce that sentence. So there's a knowledge of the world, a knowledge of the language. And knowledge of the world is much more and plays a much more important role in sentence production. He said if you knew that, if you know what it is, both AI and linguistics would be helped. He said the linguistics and AI would be both helped a great deal if you knew what that knowledge is. So the mathematical logical language that McCarthy is referring to time and again can be very easily compared to the language and methods of Navyadhyaya and Mimamsa interpretation techniques in Sanskrit. So therefore, I would say a combination of Vyakarana, Mimamsa and Nyaya with AI and computational linguistics would be fantastic, and we should in India actually look more closely. And for that, I think the linguistic departments, computer science departments, and Sanskrit departments have to come closer. I remember giving a talk in BHU long back, and there was a lecture. I had a lecture series in BHU, and the computer science department, the Sanskrit department, and linguistics, they were all on one platform. And I was surprised to see that the Sanskrit Vaiyakaranas, very, very senior Vaiyakaranas, were very open-minded and very receptive to the ideas, new ideas. Now, can machine learning-based AI benefit from Panini? Now, let's see if today we are in the machine learning field, and can machine learning benefit from artificial Panini? Let's look at that. Now, how can we make machine learning more effective? Now, to make machine learning understand deeper relationships, deeper hierarchical relationships, layers of relationships that a sentence, that a discourse embodies, we have to make sure that the deeper Karaka relations are annotated in the sentence. For example, we take a paragraph and we identify the Karaka relation cases, dependency relationships, and mark. So verb with non-verbal categories and non-verbal categories with their dependencies, we mark all that. And then they use that corpora to train machine learning algorithms. If we are able to train machine learning algorithms with such corpora, then machines will be able to understand the complex relationships that different entities in sentences have with each other. And actually, this is being done, and you would be surprised to know that Google is already annotating large quantities of Indian language corpora with dependency annotation. Now, how can we can have Karaka applications in AI? We can imagine any AI agent, any AI agent, if it has to obey our commands, if it has to understand, our instructions, it has to understand Karaka first. For example, if I tell a robot to pick up the cup from the table, it has to understand the location. I think Aadhaar, it has to understand Aadhaar, concept of Aadhaar. It has to understand the object. It has to understand the agent. Robotics will depend on this understanding. I had to see, and I remember witnessing a presentation by a postdoctoral fellow from MIT who had come to JNU, and they were researching, teaching propositions to robot. How we teach propositions to robot. When you teach propositions to robot, you're teaching Karaka to robot, right? So this is how we have to actually go from here. Now the big question is, all said that Panini is good, Panini is formal, this and that. Can we say that Panini is entirely computable? We can convert Panini to a computer program. So is Panini 100% computable? I would say no, because there are very clear semantic roadblocks towards computing Panini completely, and I'll talk about those roadblocks very briefly. Now, the basis of Panini's computing is semantics. Panini's processing is semantics. I'll take 10 minutes more, perhaps. Now, George Cardona says that semantics is the basis of all derivations in Panini, and we all know the people who are Paninians, they understand that Panini starts with semantics, actually. So whether you talk about morphosyntax rules of Panini, or you talk about syntax semantics rules of Panini, they're all dependent on semantics heavily. Ramanujam, one of my friends, he also showed his frustration that these rules are so difficult to implement. Now, one good practice, quick and dirty solution could be that we bypass these seemingly wasteful and expensive processes. Many grammarians, many AI experts conveniently try to look over the semantics and go into creating systems. We can't do that, because if we do that, we'll miss many things. In fact, we'll not be able to do anything if we miss semantics in Panini, because we'll not be able to define any of the meta terms which are progressively used, iteratively used across in Panini. For example, the definition of agent or object, which is critical for describing any relation, right? In robotics or any way you talk about it, these agents and objects are defined semantically. They derive their definitions from semantics, and I'll explain how. And these definitions require abstract semantics, which is difficult to implement at this point. We therefore have obvious semantic roadblocks to a complete computer system of Panini. Let's look at some examples and see if we can have some solutions. For example, in Panini system, some semantics, semantic conditions are in the form of, in the context of, if category A is this, when continuous activity is intended, etc., etc. These things can be handled, by creating some lists, some dictionaries, some ontology, etc., etc. But others, like the defining Karaka relations and assignment rules, would need huge ontological databases and also a lot of guessing about speaker intentions. And therefore, I would say Karaka is the most the most difficult stumbling block to across to a complete system of Panini. The Panini has three places where he defines all the Karaka relations. He calls them Karaka Sutra, about you see about 25 or so, and then he calls Vibhakti Sutra, about 71 or so, and then Karma Pravachaniya Sutras, about 15 or so. And Cardona gave this formula. He talks about the noun phrase, that noun stems they combine with noun affixes, and they give noun phrases. Similarly, verb roots combined with verb affixes, and they give you verb phrases. And these are combined by Karakas to give you complete sentences in Sanskrit. Right? So there are 6 Karakas, as you know, in Sanskrit. And the Panini, actually, the way he starts, he would first define a Karaka, then he would assign a Vibhakti to the Karaka, then he will talk about exceptions, and then he would talk about one to many, and then many to one. He'll also talk about optional situations. So you can have some Karaka sutras like this, like Kartu Ipsitamam term. This is what is karma. That which is most desired by karta is karma. And to karma you define to assign the Ditya Vibhakti. And this is the example. And then you location, say Adharo Adhikaranam. This is Adhara Adhikaran. And then you assign Saptami to Adhikaran. Grihe Saptami. And then you give exceptions. This is how Panini goes in his Karaka stipulations and rules. We have created our Karaka database, which is a very elaborate database of all the Karakas, Vibhaktis. We had a student, Sudhir Mishra, he did this work. And then Katya, Vartiga, Karma Pravachaniya, etc., etc. and mapping, etc. We have done all that. And then we've also been able to formalize each of Panini's Karaka Sutras mechanically. So, for example, this is the Kartri. In what way Kartri can be more formalized so that we can implement them. So, let's look at some difficult conditions. For example, Swatantriya. Panini defines agent, Karta, as a Swatantraha, that which is independent. So how do you define independent? And then that which is most desirable is karma. Devdatta odaram pacha. Devdatta cooks rice. So rice has to be karma because that is most desirable by Devdatta. And in cooking rice, fire is most instrumental. So fire must be sadhaktam. Is instrumental. Similarly, the sampradhan and then ablation, all those things have to be an adhika, adhar, all those have to be defined. How do you define adhar, adharo adhikaranam? And how do you define separation from a fixed point? All those things. So possible solutions, what we took actually to build a database of all Karaka Sutras, we've done that, and special conditions, exceptions, vartikas, we've done all that. And they create a synonym lexicon, a thesaurus where we can handle the conditions like in the sense of, in this sense, in that sense. So we have our Amarkosh already created in terms of database where we can look at for those specific semantic senses that a sutra comes in. So if this process is an internet problem, looks like, and a semantic classifications of verbs according to Akaraka. We have done all that also. So we have classified the verbs of Sanskrit in the semantic classes. Other possible solution could be build basic concepts centered on verb classes. So we can look at this idea, and this is futuristic. We can take semantic primitives as taken by Jack and Dor and others, and use them for Sanskrit verb classes, and incorporating Karaka informations as well. So we look at some of these templates done by Jack and Dor, etc., and look at Panini's verb classes and try to incorporate. And this model that then can be extended to other Indian languages. So finally, what I discussed in this presentation, the modern strategy of Panini has certainly inspired formal methods in linguistics, and we can trace that from Panini to Saussure, to Bloomfield, to Harris, and to Chomsky, and the successors of Chomsky in formal grammars in one way, and to creation of the artificial languages compilers in the other direction. While most Western formal models, Chomsky or others, have been modified several times and have not answered questions of ambiguity, long-distance dependency, etc., Panini has completely described Sanskrit. In fact, Panini's grammar is the only grammar which completely describes Sanskrit and has been stable for more than 2,500 years. While AI has moved in the machine learning methods, Panini's Karaka dependency is still being used for deeper learning from machines. However, abstract semantic conditions and assumed knowledge of user intentions have to be computed for developing complete robust systems. All said and done, the fact that there are stumbling blocks in the Panini's Karaka system, deep semantic context and conditions to rules have to be handled very seriously, and we have to create, as I said, a lot of databases and create routines and programs to handle that. And unless we do that, we cannot get a robust AI program in Panini. Thank you so much, and I'm very happy that I was able to finish in almost about an hour, 5 minutes or so, and I can take now some questions. Thank you so much.
Thank you so much, sir. You actually talked us through the immense scholarship of Panini and some of the foundational concepts of linguistics today. Thank you so much once again for imparting a part of your knowledge. To get to know about the application of the formal method of linguistics, reference to Panini was absolutely all gains for us. Now, we do have a couple of questions put in by the participants on the chat box. And with your permission, sir, I would like to take them up. So, sir, should we go ahead with the Q&A?
Yeah.
Okay, thank you. So the first question has been put up by Suchita Maurya. And basically, there are two questions related to Ashtadhyayi. The question says, can Ashtadhyayi be considered for learning and teaching grammar universally? And we have this kind of book. Still, we are learning grammar from so many other sources, whether good or bad. So what could be the reason behind this? Your opinion and views on this we highly appreciate. This was the first question.
Right. See, the problem is Panini's grammar has been used to model Indian languages. If you see any grammar of Indian language today, you'll see certainly an imprint of Panini. In fact, first grammar even Tamil was written on Panini's model. And in Panini's own system, there had been pedagogical tradition, or teaching Sanskrit based on Panini's grammar. Now, what should have been done actually in the linguistic departments of India and also the Sanskrit departments of India, that they should have evolved a language teaching mechanism, a language teaching method based on Panini. I'm saying not only Sanskrit but other Indian languages. Some work in this direction has been done. I remember someone did an Oriya grammar, Oriya linguistic grammar based on Panini. So something of that kind should have been done for teaching purposes. And that I think the researchers like you should take up in the linguistic department or Sanskrit department to come up with something of that kind.
Okay, thank you, sir. Now, the second question comes from Kaustubh Mishra, who actually asked, perhaps this question is not related to your lecture, so to say, but he would like to know what contribution, if any, can AI-powered computational linguistics make to settling the Aryan migration debate? So that's the question.
Yeah, Aryan migration debate now hangs on the linguistic evidence more actually, because we do not have any historical archaeological evidence of Aryan migration, and we have linguistic evidence. The latest evidence that has come from is the Bengali language of the Garhwali region. Now, the computational linguistics can do a remarkable job in going bottom up. So, for example, we have the language data from these so-called related languages, whether typologically related or genealogically related. We can look at those data and start building, building a bottom up to go up and see what kind of original language we come up with. And if you do that, I would say yes, we should do because we have artificially divided Indian languages into 4 language families. I don't know whether there is a substantial logic in that because a lot more data is not being available to us. So I would say yes, we should look at all the Indian languages data and then start doing research bottom up using computer by kind of reconstructing the immediate and remote sources from where these languages would have come up. But that would solve, I'm sure, the Aryan question.
Thank you so much, sir. Once again, thank you so much. I think your lecture today has just, opened up new vistas and, sort of made us aware with the scope of this, more scope of research in this particular area. And I guess even the chat box is actually full of that. There are a lot of congratulatory messages, a lot of praises coming out your way. And one of the questions again comes up by Dr. Purnima, who asks, sir, how can students who are not trained in AI and machine learning can work in computational linguistics? And can students with a BTech degree or an MCA can switch over to linguistics?
Oh yeah, that would be very, very necessary. See, now linguistics is a discipline big in demand today from both AI perspective and other perspectives also. So I would say yes, students doing BTech or MTech or MCA can switch to linguistics. That would be very, very productive. And also students of linguistics who have not done machine learning or AI should look up for some workshops online. This is the time when, as the corona pandemic is there, you have a lot of opportunity to look for some workshops and training programs where you can go through such trainings. And recently we organized a lot of workshops actually for public and also for our own internal groups. So you should join some of these groups, for basic training. And after you are trained, there will be a very good contribution because the good linguists are in demand today.
Thank you, sir. Thank you so much once again. I now invite Dr. Purnima Singh, Assistant Professor of English, from Vasant Kanya Mahavidyalaya, Varanasi, to deliver the vote of thanks for the day. Dr. Purnima,
Sir,
over to you.
thank you, ma'am. With lot of gratitude, I would like to thank Sir on the behalf of Department of English, Vasant Kanya Mahavidyalaya and Education for Nation. Because, sir, your lecture was really enlightening for us students of literature, how we can go back to our roots and how we can connect it to the emerging technologies of today's time was something that was really an eye-opener for many of us. And along with it, I would like to thank Education for Nation for collaborating for English for Nation for collaborating with us for organizing this wonderful lecture series where we have got such eminent erudite scholars whose lectures and whose opinions have always enlightened us to move into a new direction and new avenues that are open to us. So thank you so much, sir. And thank you so much, English for Nation. And I would also like to thank our own department, our head of the department, Dr. Veena Singh, to be the supporting pillar who always helps us to organize these lectures and seminars and symposiums. I would also like to thank Dr. Rajesh Verma, who is the convener of this, and Dr. Niharika Lal, who have worked with us to organize this lecture series. And along with it, I'd like to thank our technical staff who have always been there supporting us in whatever we need. And last but not the least, all the participants and the attendees who have helped us to make this program successful. Thank you all. Thank you everyone who have put forth their questions, and also anyone whom I'm missing. I extend my thanks and gratitude to all of you. Thank you.
Thank you. Thank you so much, Dr. Purnima. Thank you so much. As we end the session, I hope that you all must have learned a great deal today. We hope to continue with this journey of seeking knowledge together through our platform in the days to come as well. Thanks for being with us. Thank you so much, sir, once again.
Thank you.
We see you tomorrow with another exciting and enriching lecture just on English for Nation. Thank you so much. Take care.